21 as the number, we can move on and initiate the discussion slowly. Today we are going to look at contact process. Today we are going to look at contact process. Today's discussion is about contact process. Sorry for that. I was trying to reduce the volume to avoid interruption from this same machine for YouTube followers. We are here to discuss contact process. The audience on YouTube, this is a senior for industrial process, and we want to look at how we can manufacture sulfuric acid. Then we are going to use this sulfuric acid we've manufactured to combine it with ammonia and make a fertilizer known as ammonium sulphate. So the industrial processes, the one for herbal process and the one for contact process, for us to come up with industrial manufacture of ammonium sulphate. If you want to manufacture sulfuric acid, number one, you need to have the following marking areas, like I've always instantly reminded you about these marking areas. In your write-up, there should be raw materials, the raw materials required. If you can look at ours, the raw materials we have include 1, sulfur dioxide. I'm going to underline it with blue. If I'm to give a tick here, it is going to be for raw material. So that is raw material number 1. The sulfur dioxide is obtained from a chemical process, which is combustion of sulfur. This is a chemical process. Actually, it can be represented by an equation, the equation which says that if you have sulfur, which is a solid, and you burn it in oxygen, which is a gas, you get sulfur dioxide gas. So it is this gas that we use as the main raw material in manufacture of sulfuric acid. So once you make this sulfur dioxide gas from this equation of burning sulfur with sulfur dioxide, you make sure that it is purified to remove any dust and any impurities in order to make it pure and safe for use. So screening to remove impurities, this earns you a mark of a physical process. And even drying to remove water of crystallization in case of its release, remains a physical process because there is no chemical reaction. It is simply attraction of water by the drying agents. And Nisima is inquiring, are we going to write? Yes, of course, we are going to write. When we are handling, the first part A is the process of production, and the points placed on this side are the marking points we score when marking an industrial process. So whatever we are doing, the other side where I'm putting marks, I'm trying to look at how best has the learner picked out the marking points given. That's why you will see that my first mark has an abbreviation of RM standing for raw materials. Then an abbreviation of PP stands for a physical process. An abbreviation of PC stands for a chemical process. An abbreviation of CD stands for conversion to desired product. An abbreviation of V stands for vessels. Abbreviation of PR stands for purification of the product. And coherence is CH. But this CH, you will not see us giving it a tick, because by the time you get the PR and the CD, it means your steps have been coherent enough to acquire that mark. As we proceed, this dried sulfur dioxide is going to be mixed with air. So this air becomes another raw material. But the process of mixing does not require any equation. So when we say mix, mix means it is a physical process. Therefore, we are going to give it a tick of PP. You simply make a mixture of the two gases and you feed them in a contact tower, which can also be given a name of a catalytic converter. Once given a name of a catalytic converter, we shall have mentioned the vessel. So you get a tick of V, which stands for vessel. This mixture is going to be passed along heated pipes containing vanadium 5 catalyst. Vanadium 5 catalyst. If you remember the catalyst we used in manufacture of ammonia during the Haber process, we used finely divided iron. When we are manufacturing nitric acid, we used platinum. Now in manufacture of sulfuric acid, we are using a catalyst known as vanadium 5 oxide. And somebody is asking, is vanadium 5 oxide soluble in water? This oxide, if I take it to item 2, this oxide is covalent. It is a covalent compound. Therefore, it would have been insoluble in water, but one of its unique properties is that for it will dissolve. And once it dissolves, it gives you an acidic solution. That's why sometimes we shall also call it an acid anhydride. An acid anhydride, to show you that it is acidic in nature. And once it dissolves in water, it dissolves to form an acidic solution. So Elvis, I think I've explained your question very well there. So we need vanadium 5 catalyst at a temperature of 450. This temperature is similar to the temperature we used when we were making ammonia, and pressure of 200 atmospheres. Sometimes books here will differ in what they quote. Sometimes you may find when instead of 200, a book has given you 2 atmospheres. 2 atmospheres. So we can look at both either way, but majority of the O-level books have tried to look at give 2 atmospheres. So let us also maintain the 2 atmosphere thing because it's what has been requested. It is what is most common in O-level books. So we are taking it to be at a pressure of 2 atmospheres. And they will always tell you that this pressure of 2 atmospheres we are talking about is equally high pressure. So when you're talking about it, you'll say this pressure is high pressure. So if you are not sure of the value of pressure, then quote it as high pressure. If you are not sure of the value of temperature, then call it low temperature. It is 450, but considered to be a low temperature. So when you are trying to write, you consider that. Somebody is saying that on my screen I'm not seeing the work shared. When you look at the upper bar of your screen, it's going to bring you two parts. One is going to be your personal screen, and then it's going to bring Smart Science screen shared. You click that Smart Science on the upper control bar. It will direct you to the work being shared. Please, if you have that challenge, please try to look at it and see how you can be worked upon. For whoever says I'm not seeing that work, please look at that part which calls for Smart Science. You will see meeting, then you will see Smart Science screen on the upper part where there is Zoom Workplace. Click on my Smart Science screen, then you will be able to see the work clearly, the shared work clearly. Ms. Mzei Waswa, in case there is any member who still has that challenge, please you notify. Somebody says he's lost. It's me. I'm lost. I'm lost. May I get to know exactly where you're lost from so that I can ease picking you from? May I know where you're lost from? Waswa, I've seen your presence. Mm, although currently you have disappeared. I think the person who had issues of not seeing the shared work, I believe I've solved that issue. In case it comes back again, notify me so that we can move on. As we continue, all this statement is targeted to give us a product in form of sulfur trioxide. Therefore, it's going to be marked and treated as a chemical process. Treated as a chemical process. And the equation, for those who love equations, the sulfur dioxide we made, which is a gas, is going to combine with oxygen, which is also a gas, and the reaction is going to be reversible, just like the reaction of manufacture of ammonia. Then we get another gas known as sulfur trioxide, which is SO3 in gaseous form. So we multiply sulfur trioxide by 2, even sulfur dioxide will be multiplied by 2 in order to balance the equation. Somebody says I was a bit late from the start. May I get to know? We've begun with manufacture of sulfuric acid, which we called the contact process. Our main raw material has been sulfur dioxide, which we make by heating sulfur in oxygen to get sulfur dioxide. Then what we do next is to clean this sulfur dioxide by screening it, which is a physical process. Then we also dry it. Thereafter, we mix it with air, so air becomes another raw material. Then we feed it in a vessel. You are allowed to use at least one of the two. You either call it a contact tower or you call it uh, a catalytic converter. One of the two statements gives you a vessel. Then we proceed by converting the sulfur dioxide we've made to make it sulfur trioxide. And this one is done in presence of at least 3 conditions. One is a catalyst known as vanadium 5 oxide. Another is low temperature of at least 450 degrees Celsius. And lastly is high pressure of about 2 atmospheres, forming sulfur trioxide gas. So that's where you've got us from. When we get sulfur trioxide, this sulfur trioxide, yes, it is soluble in water, but we don't take that route, because when you dissolve sulfur trioxide in water, the heat given off is too much, which will cause explosion, and no lab can contain that explosion. So to take the safest pathway, you get this sulfur trioxide and you go ahead and dissolve it in some concentrated sulfuric acid, very little concentrated sulfuric acid. With that, we get a product known as the oleum. We get a product known as the oleum. This will receive a tick known as a chemical process. And by show of an equation, because normally they are members who love equations, our sulfur trioxide, SO3 gas, dissolves in some very little sulfuric acid, which is a liquid. The byproduct is an oleum. To get an oleum, simply add the two reactants the way you see them, and you get the total. Hydrogen remains 2. Sulfur, if I get this sulfur from sulfuric acid and I add on the sulfur from sulfur trioxide, the sulfur becomes 2. Then when I add up the oxygen, 3 from sulfur trioxide and 4 from sulfuric acid, I get 7 oxygens, and this is a liquid. So that liquid is known as the oleum. That is a chemical process. Then the oleum is going to be diluted. Dilution receives a mark of a physical process with a little amount of water to form. We shall form sulfuric acid. Our sulfuric acid is conversion to desired product. Then the only mark we have not yet given is purification. This concentrated sulfuric acid is purified at screening to prevent poisoning of the catalyst, to remove impurities, to prevent poisoning of the catalyst. The moment impurities are removed, then we shall say this liner has purified. So you'll get the PR from there. Last equation, for those who would love it, our oleum H2S2O7 in liquid reacts with water, because we have added water there. The product is going to be sulfuric acid, which is liquid. If you look at the hydrogens on the reactant side, 2 from the oleum and 2 from water, they become 4. So I will simply multiply sulfuric acid by 2. You will find out that the equation will eventually balance itself. So ideally, that is the industrial process of production of sulfuric acid. In case of any query or concern, notify me on time. You can notify me before we proceed to side effects and then the social benefits. Normally, in our normal all day life, where you see plants that extract sulfur, where there are plants that extract sulfur, there will always be plants which manufacture sulfuric acid, simply because sulfur will liberate sulfur dioxide, which is the main raw material for manufacture of sulfuric acid. So normally, where they place plants which extract sulfur, there will always be plants which manufacture sulfuric acid. And where there are plants which manufacture sulfuric acid, there will always be plants which manufacture car batteries because it is the main electrolyte. So to ease costs in transportation, those plants are always near each other to simplify work. The oleum is a liquid which gives us large amounts of concentrated sulfuric acid. For every 1 mole of the oleum, you get 2 moles of sulfuric acid. So you simply dilute with very little water because this sulfuric acid we shall have made is 98% concentrated. So you only add, it means we added only 2% of water. So if a learner, instead of saying with a known amount of water, if a learner comes here and replaces these words in a circle and says with little water, that learner is correct because very little water is used to dilute the oleum. Members should notify me through our chat whether we are good to go. Then two, I will request one of the participants here. Let me see through. Last time I used Telpist. I think I'm going to use Shivan. You were among the very first people on Zoom today. Actually, we are the very first member to join the meeting. So Shivan, you take a screenshot. You're going to share these notes in our common group. A screenshot of the industrial preparation of sulfuric acid. As we proceed to the next slide, the next slide is going to talk about basically the side effects, their impact and occurrence, and then how to mitigate them. We are going to also have the social benefits of the industrial process and how we can look at them generally. So I believe by the time we've come to this point, I believe members can give me as many dangers as possible, as many explanations as possible, so as to obtain a very clear approach on whatever we are writing. There will always be release of sulfur dioxide, which causes death of aquatic organisms. Mentioning this, has identified the danger. A danger coming from release of sulfur dioxide from the industrial plants and also sulfur trioxide. Why will they cause death of organisms? These gases are acidic, therefore will form acidic rain, which alters pH, making it unfavorable for organisms. You have explained. So what should we always do? Installing waste fume filters to remove the acidic gases before discharge. Dangers mitigated. Sometimes we shall say use catalytic converters. Use catalytic converters. Reason being, sulfur dioxide is a reducing agent. Before I leave this section, I'll try to handle a format of responding to an item 2 question which involves either sulfur dioxide or sulfur trioxide. As we move on, poor disposal of waste effluents will cause death of organisms. I think this one we agree, danger identified. Reason being, the wastes are going to contain sulfuric acid, which will alter pH. Danger has been explained. Therefore, it would be better to neutralize the acid before discharge. How do we normally treat the acid? Mitigated by treating the effluents with, we normally use weak alkalis to neutralize the acid before discharge. Social benefits have been always discussed, always explained very well. And in our write-ups about social benefits, we have always emphasized the following. One, make sure that when you talk about employment, you look at areas in chemistry which will lead you to be employed there. Areas in chemistry. Anyone may have identified very many, but for us we shall say any one area identified. You will have a social benefit given. Then earning income will give us a social benefit explained. And how has it impacted on local people? The social benefit impact will be given, so that we get 6 scores from here. So ideally, I believe we can now give as many social benefits as possible. We have given 3, but we have a community that can give more than 3 in this class. If you look at this, allows industrial development. This is a social benefit. Emergence of industries that manufacture sulfuric acid derivatives in the community. E.g., you can even give an example, e.g., battery manufacturing industry, battery manufacturing industry, e.g., the soapless detergent manufacturing industry, soapless detergent manufacturing industry, These are all things that we would love to use sulfuric acid. Then this one will impact people by improving their economic growth. So basically, that's how we shall have sulfuric acid manufactured, and that's how we discuss the contact process generally. Unless when there is a question on the dangers and social benefits, but I believe there are more additions we can make. So every member of the class will come up with a new additions in what we have presented. I'm trying to look at our our enrolled list today, but unfortunately, I'm not seeing this member. I was expecting a member from Lubiri to be joining us this morning. I believe the specimen may join us later on or tomorrow, but we are going to be having new members on board who are not part of Olam community, and we shall be working together to see that we can make this a success. I will inquire from the person I requested to take a screenshot. Are we good to go? Shivan, are we perfect to move on so that we handle sulfur dioxide as an item 2 concept, even sulfur trioxide as an item 2 concept, because these two guys may be brought in item 2 and you're asked to mention their categories with reasons to give some of their properties and then the possible dangers. But I believe for the dangers, we have tried to look at them. Therefore, they will not be a burden to us. Allow me to first share for the case of item 2 mode of answering. Alpha is trying to say that Shivan is sleeping. Could be we are going to tell Shivan to put a video of herself. Actually, just activate video so that we see whether you are sleeping and we confirm. Yeah. Hey, this specimen is not sleeping. Please, the specimen is not sleeping. As we proceed, gently, we have, I'm going to share a whiteboard first before we proceed to handle these two ideas as item 2. How would you respond to them if a question comes in item 2 and it involves either sulfur dioxide or sulfur trioxide? How would you handle those questions? On one side, I have sulfur. I'm going to separate my board here. On one side, I have sulfur dioxide, and on the other side, I have sulfur trioxide. According to the basis of assessment, begin with category. Start thinking about the category. Sulfur dioxide can be covalent. If not covalent, it is an acidic oxide. Those are the those are the only two possible categories you can give. When it comes to sulfur trioxide and we request for category, you can think of still covalent. If not covalent, think of an acidic oxide. So those two are the first area is shared amongst both of them. As we move on, we meet properties. And among properties of sulfur dioxide, this guy is a reducing agent. That's why when we want to mitigate it, we use a catalytic converter because it can be oxidized. Number two, turns moist blue, litmus paper red. 3, it's a bleaching agent. Can be used to bleach wool. The wool that is used to make woolen blankets, woolen coats is bleached by sulfur dioxide. This guy is soluble in water, forming an acidic solution. However much it is covalent, and we normally say that covalent compounds are insoluble in water. This one is soluble. So when you're writing about it, you have to be very keen and concentrate on its unique property. Somebody says, can it also bleach the skin? Please, you're more handsome and more beautiful on a normal skin. Don't bleach yours. We still need you in good shape. Next idea, apart from being soluble being soluble in water to form an acidic solution, this guy, sulfur dioxide, is denser than air. So when you open understanding chemistry and you look at sulfur dioxide, you will see it being collected by downward delivery, simply because it is denser than air. Colorless gas with choking smell. If you remember the times we did experiments concerning rate of reaction, and we are dealing with either concentration or temperature. That gas which was being given off when we mixed the acid with the thiosulfate was making you choke, was making you cough somehow. So that gas was sulfur dioxide, which also has choking smell. Remember, on this part, we tell learners that we need Na Na4 only. So this is 1, 2, 3, 4, 5, 6. I think I have the right to stop there and be like, add on the others. You can equally add them on because they are quite many. I can add on another before I proceed to the next. This guy here you're talking about burns in oxygen to form sulfur dioxide, sulfur trioxide. Burns in oxygen to form sulfur trioxide. As we proceed, we meet uses. These uses normally are going to come from the properties we've discussed there. So number 1, it is used to bleach wool, used to make blankets, used to bleach wool, used to make blankets. That is one of the uses. Simply because the property here we are using is that this guy is a bleaching agent. This guy is a bleaching agent. So we are tapping on that property to explain it very well. Then 2, we shall also see that it is used as a raw material, in manufacture, of sulfuric acid. Used as a raw material in manufacture of sulfuric acid. Why is it used? Simply because the gas is acidic. That's why it is used in manufacture of sulfuric acid to produce another acid. So crucial on that. There are still very many others you can add on, but allow me to look at those 2. Reason being, as a learner, we expect you to give us any one use. So why should I give you 100 of them? More areas of concern can be still looked at under hello? No, Sasha agende, olaba waggulu wane wabeera Zoom workplace, atapinge ewali erinnya lyange Smart Science, bakati ye atabika ataddeko kiki ekifaananyi alaba kiki nga ye omuntu. No, kemugambe wano waba ali online. Now, I'm being told by my colleague that one of us is not seeing the work clearly. So I'm requesting that person who is not seeing the work, I'm requesting you to simply first leave the meeting, then rejoin. It will directly give you the work. You leave, then join the meeting again. You will be able to see the work clearly. That's my humble request. Pardon on human impact and mitigation. I've not yet given the impact and mitigation of these two, but from manufacture of sulfuric acid, we've seen them already. Actually, if I'm to look at impact, impact is shared on both sulfur trioxide and sulfur dioxide have the same impacts. One, death of organisms. Two, poor plant growth. Poor plant growth. Three would be still suffocation, but it results into death. Reason being, both of them are acidic. Therefore, will give us acidic rain. Because they give us acidic rain, which alters pH. Which alters pH. It can be pH of water, pH of soil. If it alters pH of soil, plants will poorly grow. That means we need a mitigation. Mitigation for sulfur dioxide, catalytic converters. Because it is a reducing agent, so we need the catalytic converters to be installed in chimneys of industries to purify the waste fumes, to reduce emission of sulfur dioxide into the atmosphere. So this impact, ideally, is similar to the impact we looked at when we were discussing the industrial process of the industrial process of contact process. When it comes to this side, properties, still there are properties which are similar. One, this guy here turns moist, blue, litmus, red, which means it is also acidic, similar to sulfur dioxide. This gas is also soluble in water, forming sulfuric acid. Although the reaction is too exothermic, that's why we don't use it in contact process, because it will explode and the heat will not be accommodated normally. This gas is also denser than air. That's why it is collected by downward delivery. Exits as white fumes. So it is not as colorless as you see sulfur dioxide red. It exists as white fumes. So you'll be able to know to identify it and separate it from sulfur dioxide. And we normally need Na4. From there, we come to uses. Used to manufacture sulfuric acid, since it's acidic. Danger is the same. Dem sulfur dioxide equals sulfur trioxide. Same danger. So when you talk about the dem, come and bring these two. You will be able to identify. The other danger would be destruction of metallic structures. Then lastly, corrosion of buildings. Corrosion of buildings. All the explanations of those four dangers is acidic rain. There is no alternative. You will bring them to acidic rain and be able to explain them. So unless when there is a member who has a concern on manufacture of sulfuric acid and then how to handle sulfur dioxide, sulfur trioxide as an item to number, you raise up your hand, you will be able to be given chance to have something to say. I'm seeing member here talk to us.
Good morning, sir.
Good morning too.
Yeah, teacher, like there's some scenario which I encountered, like it was about crops. There was a lot of rain, and then after the crops had some, the leaves started wilting, drying up. Can it be as a result of the acidic rain, or it does not have any effect with that thing?
Uh, was the question in our field of chemistry?
Yes.
Yeah, that is likely to be acidic rain. But if it was in the field of agriculture, the too much rain may also cause leaching of soil nutrients. But if it is chemistry, connected to acidic rain. So you look at
Okay.
gases which may cause acidic rain. Okay? Actually, these four impacts I've stated here: destruction of metallic structures, death of organisms, poor plant growth, corrosion of buildings, are dangers of sulfur dioxide. They are dangers of sulfur tri. They are equally dangers of chlorine gas. If you see chlorine gas in item 2, the same dangers should be brought. Aya. I believe we are good to go. So when you have your sulfuric acid, when you have your sulfuric acid manufactured, and you equally have ammonia gas manufactured. Remember, this one was from Haber. This one is going to be from contact. You will be able to get a fertilizer known as ammonium sulphate. This one becomes a fertilizer. You will multiply, I believe, ammonia by 2, and the equation will balance. So when I want to manufacture ammonium sulphate, I'm going to write how to get ammonia from Haber, how to get sulfuric acid from contact. Then I join the two, combine the two, get ammonium sulphate, which is a fertilizer, evaporate it to crystallize. so that this one becomes a desired product and this one becomes the purification, and we get done. So that's how we are going to plan on manufacture of ammonium sulfate as a fertilizer. So I want to look at this process of production of ammonium sulfate as a fertilizer in our next meeting. But for this meeting, allow me to look at ammonium sulfate in the remaining time. Allow me to look at ammonium sulfate as an item 1 number. If remember, we told you in item 1, fertilizers can be wrote. The previous slide, please. I request that I conclude with this one and we get a break because it is very short. Very, very short. Ammonium sulfate as a fertilizer. In item 1, we shall look at the product, category, and function. So we shall say ammonium sulfate is an artificial fertilizer. I'll give you a tick for category. Fertilizer gives you product automatically. So mainly category mentioned, and I'm left with function. It is used to boost crop production by adding nitrogen into soil, increasing its fertility. I'll give you another tick here, so you have given me the function. So category and function mentioned will give you the 6 scores because you deserve them. The word fertilizer automatically represents the product. I may not consider that so much. I want to look at the other factor, the DEM. Prolonged use of ammonium sulfate causes this fertilizer is acidic in nature, so it will cause poor crop yields. Why? Since it's an acidic fertilizer. An acidic fertilizer that alters soil pH, affecting plant roots. How can I mitigate? Prevent it by internet connection is unstable. Prevented by addition of quicklime. Sometimes learners want chemical names. Calcium oxide to neutralize the soil pH. As you continue using the fertilizer. Lastly, as I wind up, we conclude item 2. Item 1 with the last part known as evaluation. As you evaluate this guy, simply know that it's effective due to a high nitrogen content. That is its advantage. It's one of the advantages of using ammonium sulfate. However, you must be in comparison if it is compared with ammonium nitrate. Ammonium nitrate, this one has a higher nitrogen content. Than ammonium sulfate. Thus, it would be better. Ammonium nitrate is better than ammonium sulfate. But if it is compared with local content, expect ammonium sulfate to be more effective because it gives you a higher nitrogen content within a short period of time. So that sums up the day for chemistry. My next meeting with you, we shall handle the manufacture of ammonium sulfate and be able to complete all manufactures of fertilizers. Allow me to end the meeting from here. Thank you for your patience and positive attendance. Shivan, we expect our notes to be shared immediately after this meeting ends. Thank you. Kati bagenda bakendeera.